Welcome to Unit 10, all about polar graphs and complex equations. Day 1 of our notes is going to be on polar coordinates, plotting points, and converting in between rectangular and polar coordinates. These are learning targets 1, 2, and 3, converting between rectangular and polar coordinates, plotting a point given the polar coordinates, and finding all polar coordinates in a specified range that are equivalent to a given rectangular coordinate. Start off with what the polar coordinates even mean, because this is brand new to you. Your whole life you've seen a set of XY coordinates where you are given a point and it has a horizontal distance and a vertical distance. The polar coordinate system is set up differently. It's helpful because it can simplify some of the more complicated rectangular equations. It's useful a lot in calculus, so you will see it again. Basically, you have a plane with a point O, which is the pole, which we would normally have called the origin, and a ray away from O, the polar axis. So we have the polar axis instead of the x-axis. Each point in the plane is assigned polar coordinates. R is the distance away from O to P. So if you've got a positive R, you'll be moving from O to the right. If you have a negative R, you'll be moving from O to the left. And theta is a directed angle. So remember that positive angles rotate counterclockwise and that negative angles rotate clockwise. So for example, if I were to plot the point to 30 degrees, I would go to the right 2 and I would rotate along that axis to the 30-degree mark. So here's my point P. Couple of notes that you might want to add for yourself. It's easiest to go over R and then rotate along that radius counterclockwise to that angle. It gets a little more complicated if you're trying to do the angle first. So easiest to move R and then rotate theta. Remember that positive angles go counterclockwise and negative angles go clockwise. So remember, we always opened up or opened down. Positive angles open up, negative angles open down. The first few slides are really just practicing plotting these points. It will require that you remember your unit circle values. So it might be helpful for you to refresh your memory or get out your unit circle to help as we go through these. 2 pi over 3 is going to be out 2 to the right and rotated around a 60-degree angle, pi over 3. So my point should land here. Negative 1, 3 pi over 4 is going to be to the left for the negative 1. 3 pi over 4 is a positive angle, so I have to go counterclockwise that much. 3 pi over 4 is one of those 45-degree reference angles. If I were going from normal positive 1, 3 pi over 4 would be that 3/4 of the way around my pi. 3/4 of the pi. So I'm going to go this time negative 1 and then 3/4 of the way around the pi in that counterclockwise direction, and it's going to leave me in the 4th quadrant for Q. Final example is 3 45 degrees. Over 3, rotate 45 degrees. Positive, positive. You should end up with R in the 1st quadrant. Next 3 examples. Negative 4, negative 60. Negative 4 degrees is going to go left, or negative 4 as your R is going to go left 4. 1, 2, 3, 4. So now I'm out here on that negative polar axis. Negative 60 degrees. Well, negative angles rotate clockwise. So from here, rotating clockwise, 30 degrees, 45 degrees, 60 degrees, my point should end up in the 2nd quadrant. T starts at positive 5 on the polar axis, 1, 2, 3, 4, 5, and rotates 7 pi over 6. That's a positive angle, so we go counterclockwise. 6/6 of a pi would have been a whole pi, and 1 extra pi over 6 is another 30 degrees. 1 extra pi over 6. There's my T in the 3rd quadrant. My last point is 320 degrees. I'm going to go positive 3 and I'm going to rotate 120, which is that 60-degree reference angle. My point ends up in the 2nd quadrant. We will have practice tomorrow in case you need it on those plotting. Okay, next is converting between polar coordinates and rectangular coordinates. So this is all about imagining these points on the same axis. So this point is either r theta or xy. So you're imagining this point both directions. So you see I've got my x comma y, my horizontal and vertical distance, and I've got my r, my radius, and then my angle theta that I rotated through. We've got two different equations that are going to help us solve, and I want to just quickly show you where they came from. It's all about right triangle trig. If you just think so ka toa, and you write yourself a ratio for sine and cosine, sine of theta would have been y over r, opposite over hypotenuse. If you solve this for y, you'd multiply by r on both sides. You'd get y equals r times sine of theta. And we have that over here. And then if you write a ratio for cosine, cosine of theta would have been the adjacent over the hypotenuse. Solve that for x, multiply by r on both sides, you'll get r times cosine of theta equals x. And you'll see we have that equation as our other one. Now in order to convert, you're going to plug in the r and you're going to plug in the theta, which means that you are going to have to remember our unit circle angles and how to evaluate sine and cosine. So you'll see over here on my slide, I've sung our song. Do you remember the song? 1, 2, 3, 3, 2, 1, 2's under every one, square root where there is no one. You put it all together. You can add in a row for tangent if you need it, but we don't have tangent in either one of these formulas. And it's going to help us with our unit circle angles, 30, 45, and 60. Along with the song, you're going to have to think about ASTC. That's the last thing you're going to have to think about. And remember, that tells you what's positive in each quadrant, ASTC. Think about that as well. Okay, so the next examples are finding the rectangular coordinates of the point with the given polar coordinates. So we're going to use our little formulas. We're going to say, okay, x equals r times cosine of theta. We're going to plug in r and theta. 3 cosine of 5 pi over 6. So I need to think about where 5 pi over 6 falls. Well, that's 5/6 of a pi. Pi over 6 is a 30-degree reference angle, and I'm sitting in the second quadrant where sine is positive, which means cosine will be negative. Cosine of 30 is square root of 3 over 2. We decided it'll be negative because it's in that second quadrant, times 3. Multiply this together, you're going to get negative 3 radical 3 over 2 as your x value. Plug in y. Y is supposed to be r sine of theta. Plug in your r and theta, 3 sine of 5 pi over 6. 5 pi over 6 is that 30-degree reference angle. Sine in that quadrant is positive, so this is positive 1/2 times 3, which is going to get you 3/2. So I have an x value of negative 3 square root of 3 over 2, and a y value of 3/2. And I put it all together as my xy coordinate pair that's equivalent to P in that polar point. Moving on to the next example, 2, negative 200. I'm going to go ahead and skip straight to the plugging in phase. My x is going to be 2 times the cosine of negative 200 degrees. Well, negative 200, if I think about where it would have opened down. Negative 200 degrees is going to be in negative 180 and an extra 20. It's going to be in that second quadrant, but this time with a 20-degree reference angle. That is not one of our special right triangles. So instead of being able to do this with my exact answers, I'm going to have to use my calculator since that negative 200 isn't on the unit circle. So use your calc since negative 200 isn't on the unit circle. Okay, and then I'm going to do the same thing for my y. Y is going to be 2 sine of negative 200. And I use my calculator, and I should get negative 1.879, 0.684 as my coordinate for Q. Example 3, negative 4, 5 pi over 4. Plug it in. Your x is going to be r cosine theta. 5 pi over 4 is on our unit circle because it's a pi over 4 reference angle. 4/4 and an extra 1/4. So it's sitting in the third quadrant. ASTC. So I'm in that T quadrant. So both sine and cosine will be negative. Negative 4 times negative. Let's think about that. 45-degree reference angle is going to be 1 square root of 2. So I'm going to have 1 over square root of 2, or square root of 2 over 2 if you're using the song, which is going to get you 4 over square root of 2, or if it's rationalized, 4 square root of 2 over 2 is going to equal just 2 square root of 2. I would accept either answer. For y, we use sine instead. But since it's that 45, 45, 90, it's still going to be the same value. You're still going to end up with negative 4 times negative 1 over square root of 2, or square root of 2 over 2. So it's going to be 4 over square root of 2 again, or 2 square root of 2. Again, I would take either answer. So your pair is either 4 over square root of 2, 4 over square root of 2, or it's 2 square root of 2, 2 square root of 2. I think you can probably tell which one of those is nice and neater and came from the song, that 2 square root of 2. Okay, last direction we have to go is moving from rectangular to polar, which is a little more complicated. You notice we still have the same picture with our r and theta. R is our hypotenuse, theta is our angle, your x and y pair in that same picture for your point that's either named xy or r theta. Okay. We can come up with new equations this time. The first equation is r squared equals x squared plus y squared. Well, sure enough, that's coming from our graph. That is just simply the Pythagorean theorem. A squared plus b squared equals c squared. Our next equation is the tangent ratio for the graph. Tangent of theta equals y over x, opposite over adjacent. And that's just, again, our good old SOHCAHTOA ratio. Why are these two things helpful? Well, here we need something, an equation for r, and we need an equation for theta, because those are the two things we're going to have to solve for. If I solve this equation for r, I'd take the square root. So r is going to be the square root of x squared plus y squared. And remember, when you take the square root, what has to go out front? Don't forget your lovely plus and minus. You're going to have both the positive radius and the negative radius, because you can either move right and rotate or move left and rotate. And then tangent of theta equals y over x. Remember, to solve for your angle, you have to take the inverse. So theta is going to be the inverse tan of y over x. Okay, so these are our two equations that we'll use in converting backwards. Pythagorean theorem and SOHCAHTOA. All the basics that we already really know about. Okay, find the polar coordinates of the point with the given rectangular coordinates. Make sure you all find all possibilities that satisfy these conditions. It wants all the angles in between 0 and 360 and including 0 and 360. It also wants the angles in between 0 and 2 pi. Well, it's just saying I want the angles in degrees and in radians. Here are your steps. Step 1, think about where you're going to plot this point. What quadrant will it be located in? Use your equation, step 2, to solve for r and theta. So you use that Pythagorean equation and tangent equation to solve. Then step 3, use those values or other theta with the same reference angles. Don't forget about those reference angles in the other quadrant to find the points. Our first example is negative 1, 1. So we think about plotting negative 1, 1. Where will it end up? Well, that'll be in the second quadrant. That's the S quadrant. I'm going to use my equation to come up with my parts. So my r squared is going to be x squared plus y squared. That's going to get me 2 is r squared. When I take the square root, I'll get plus or minus square root of 2. If you skip straight to the square root, that's fine as well. Then I find theta by taking the inverse tan. Opposite would be the y over adjacent. Well, tangent being -1, that is one of our unit circles. Tangent is negative in S and C, and being 1 over -1 just means those two sides are a 1, which means we're looking at a 45-degree reference angle in the second quadrant and in the fourth quadrant. That would mean theta is either 3 pi over 4 or 7 pi over 4. 4. Which is 135 degrees or 315 degrees. Because we need to think about it both in degrees and radians based on that example. Okay, so A, it wants all the parts, or all of the possibilities from 0 to 360. So let's think about this. I know my r value is the square root of 2, so I'm going to go over the square root of 2, positive square root of 2, and then I would have to rotate a positive angle, that's that 135 degrees, to get to S, 135 degrees. So that's with the positive r value. If I do this again with the negative r value, this time I would have rotated, or I would have gone left that square root of 2. Now I'm going to have to move, again, we want positive angles, so I'm going to have to go around 2 quadrants, 3 quadrants, and then that extra 45 degrees, which is the 315 degrees that would make this second match. So negative square root of 2 is going to go with 315 degrees to match up. For part B, put those degree measures into their appropriate radians. Square root of 2, 3 pi over 4, or negative square root of 2, 7 pi over 4. For example 11, example number 11, you've got -3, 0. So we're going to think about where that's going to be plotted. -3, 0 is going to be right here. That's a quadrantal angle, which is actually going to make our lives a little bit easier for this r and theta. Start off by solving for r. X squared plus y squared. You're going to get 9 as r squared. When you take the square root, you get plus or minus the square root of 9, which is plus or minus 3. So I know my radius is plus or minus 3. Then I have to think about my angle. My angle is going to be that inverse tan of your y over x. Inverse tan of 0. That's a quadrantal when we have those tangents of zeros. And tangent is 0, right where that point is sitting up there, at -1, 0, where sine over cosine, tangent, is 0 over -1. And it's also 0 at 0, where sine over cosine is also 0. Okay, so I get a theta of either 0 or 180. Or, since 270 is also, or sorry, 360 is also included, we should put that on our list since 0 is on our list. So I know my angle is 0, 180, or 360, which is either 0, pi, or 2 pi. Put together your possibilities. Part A asked you for all the degree possibilities. Okay, if I go +3, then I'd have to rotate a positive 180 degrees. If I go -3, I'd have to rotate, well, -3, that means I'd rotate nothing, 0 degrees, or a full lap, 360. Okay, then in part B, we repeat the process, but this time with our radians. 3 pi, -3, 0, and -3, 2 pi. Final example, are 2, 3. So we're going to start off by thinking about where that point's going to be plotted. 2, 3 is going to be in the first quadrant. Okay, we use our radius squared, x squared plus y squared. 4 plus 9, that gives me 13 as my r squared, which is going to give me an r of plus or minus the square root of 13, which isn't pretty, but it works. Moving on to solve for theta, we're going to use our tangent ratio. So it's going to be the inverse tan of our opposite, our y, over our adjacent, our 2. Well, 3/2 is not one of the ratio on our unit circle. And when it's not on our unit circle, what do we have to default to? Our calculator. So we use our calculator instead. Our calculator is only going to give us one answer. It's going to give us, and this is going to depend on if you're in degrees and radians. So you're going to have to do this twice. Do in degrees and radians. I typed this in first in radians, in radian mode, and I got a theta of 0.983 radians. It's a decimal. It's really lovely. That tangent ratio was positive, which is why it gave us an angle. 0.983 would be in the first quadrant, about 1 radian. Remember marking that off when we marked on our unit circle. 3.14 radians would be that full pi, so 1/3 of that or so. So this is a first quadrant angle. That's where tangent's positive, which is why it gave us that first quadrant angle of 0.983. The other place where tangent is positive is in the third quadrant. So while this is sitting on my calculator, I need to consider how to get that next radian measure. Well, they're going to have the same reference angle. So this angle in the third quadrant has gone that theta plus an extra pi. So I'm going to add pi to that answer, and I'm going to get 4.124 as my next radian answer. Then I'm going to use my calculator to do this in radians, or in degrees rather. And in degrees, when I plug it in, my calculator gives me 56.310 degrees. So if I think about that being plotted, that's also a first quadrant because your tangent value was positive. It's also positive in the third quadrant. Okay, so I need to think about this being 180 degrees plus that theta. So I'm going to add 180 degrees to that 56, and I'm going to get 236.310 degrees. So I have my 2 degree angles. And then I just have to remember that my whole goal is to get back to this point, 2, 3, in any combination of these angles and the radical 13 as my radius. So I start putting it together. Part A wanted us to do this in degrees. Well, if I go a positive square root of 13, I'm only going to go that first quadrant angle, 1 quadrant worth of moving. So I've got positive square root of 13, 56.310 degrees. If I go negative square root of 13 instead, then I'd have to rotate 2 full quadrants and that extra piece, 2 full quadrants and that extra piece, which is the second angle that I picked out. So negative square root of 13 would have to pair with 236.310. Then we use our corresponding values for radians to come up with part B. So we have positive square root of 13, that first quadrant angle, 0.983, and we have negative square root of 13, and that third quadrant angle, 4.124. We've put it all together. And that's it for polar coordinate and coordinate conversion.